Okay, all right, here we go. Okay, so the first thing that we're going to cover are, well, the first things are some ECMAScript 6 concepts. So feel free to chime in with any questions that you have. You can also do a little like hand raising thing. But all right, so ES6. What is ES6? It's ES6 is it's a newer version of JavaScript. So there's all of these high up contributor people that help kind of manage the future of JavaScript and the different features and stuff like that that get accepted. You have these meetings and discuss the pros and cons of all the different the different proposals. Anyway, so ES 2015 or ES6, those are the same thing. Is the the newest version of JavaScript. It's not totally supported in the same way across all browsers and environments, but that support is gradually increasing, and so this is what everything is going to. And so throughout our course, we're going to be using ES6. Everything's going to be in ES6. So it's having said that, though, in order for ES6 to run consistently on all the different browsers, your ES6 code actually has to be compiled down into ES5 code, or the original JavaScript, which is what we did in our JavaScript mini bootcamp. So if you look at this, so right here, there's just this is some stuff that I was actually demoing earlier. But if I just do const x gets 5, and I'll zoom in a little bit, you can see here, well, it turns it into ES5 code. So it's, I think there's something else that they do here to check to make sure that the consts aren't getting overwritten and stuff like that. But everything that you write gets transformed into ES5 code underneath the hood. All right. So that being said, it's compiled very efficiently, and your ES5 code is going to be really good. So it's yeah. So just see. So there has to be that compilation step in order for ES6 to work 100% in the browser, but it's a good step. So all right. So we're going to go through just some of the basic, most commonly used features in ES6. Ones that you're going to need to know for the project tonight. So the first one is, what you're used to is, var x gets 5. So, and again, I want to reiterate, when I am pronouncing my code, when I see an equal sign, I say gets, because we're not comparing equality here, like in an if statement. So we're doing assignment. We're not comparing equality. So I say get, it gets. So x gets 5. All right, so var x gets 5. So now in ES6, what we do is const x gets 5. All right, so var it's still there, but you shouldn't use it. So it's again, there's opinion with all these different things, and different people will say a lot of different opinions, but it's widely widely considered the best practice is just use const unless you can't, and then use let. And so what const does is it defines a variable, and then if you assign it a new value, then it will throw an error. So if we go x gets 10, sorry, if I go x gets 10 and then I try to run it, there's going to be an error, and it's going to appear down on the console somewhere. But yeah, line 3, yeah, x is read only. So. But if I reassign it like this, or if I make it a let, then we can reassign it. There's no issues. So if I go down here and console.log x, then everything will print out just fine. So the rule of thumb is don't use var, use const. Always use const. And if there's a specific instance where you can't use const because you have a variable that you need to reassign, then use let. So use const unless you need to reassign a variable. Generally, the times when you're going to need to reassign a variable are inside a for loop. So that's when you would use it. Obviously, you couldn't use a const here because I is getting reassigned. All right. Okay, so the other key distinction is that const and let are both block scoped. So if I have an if statement here, and I go var x gets 5, and I come down here and I go console.log x, and I run that, 5 prints out just fine. Because in ES5, variables are their function scoped. And so the only thing that limits their scope is if they're inside of a function. So, but right here, x is inside of this if statement block. So that's not a function. It doesn't create a new scope. It doesn't block it at all. So if I switch this to const, though, and run it, it says error. X is not defined. And that's because const now lives just inside of this block. You know, before, you know, y would only behave that way if it's inside of a function. You know, so the variables live inside of functions. Whereas, so with const and let, they're block scoped. So if this is an if statement or a for loop, they will only live and exist inside of that if statement or for loop or anything else that's nested inside of it. Okay, so just remember the rule of thumb, always use const. If you can't use const because you have to change it, then use let. So generally, you know, I'll be writing const all the time, and then I'll find that I get an error because I reassigned something, and so I go back and switch to let because I intended to do that. But you do that for it helps your code be a little more stable, so you're not accidentally overwriting a variable that you didn't intend to. There's a lot of good benefits that come from that. All right, so in our class, I am never going to, or I'm going to really try hard not to, but I'm never going to ask a question and then have a student volunteer the answer. It's always going to either be cold called, so I'm either going to randomly call on someone. We do that that kind of helps keep people on their toes, and generally, if I let people just self-select to give a volunteer an answer, then usually there's the one student that understands everything, that's answering all the questions, and the teacher thinks that he's, you know, that the students know everything and they're learning it great. But in reality, there's the one sharp student who knows it, and everyone else is totally lost. So, so we call on people. We also, you know, we'll do polling and things like that, so that way, you know, we can get a picture of. Just, yeah, how you guys are coming along with this material. So, all right, so if everyone inside of the chat Slack, if you could type a 1 if you don't understand this, like a constant, like you're just lost on the concept, a 5 if you know you got it and I'm just repeating myself and I need to move on. So, you know, 1 to 5, put a number in there inside of the chat. All right, great. So this is kind of our example. So, and then generally, if I start seeing numbers that aren't 5s, then we'll stop. And all right, Austin, do you think you can turn that 2 into a question? You got a question about constant let? No. All right. Okay, so we'll move on. All right. So the next thing that we're going to cover is well, we're going to cover arrow functions. All right. So in ES5, we had function declarations like that, and function expressions like this. So in ES6, how I want you to write your functions is like this. You're going to go const foo gets, and then you'll define an arrow function. So this is how I want you to write your functions. And generally, we always want to default to an arrow function, again, unless you specifically need to be binding a this context, or this is, you know, the this keyword is really important. And we're going to go into that a little bit later, but this is the syntax that I want you to write your functions in now. All right, so the next thing, okay, so generally with arrow functions, you know, you've probably seen them a little like used more as callback functions. So they're a really good syntax. Essentially, they're a way of creating an anonymous function. That's what an arrow function is. This is the replacement for anonymous functions. So let's do const array gets 1, 2, 3. So we can go array dot for each, and then we can go item. Now let's go console.log item. All right, so clear this out, run that. You can see it prints them all out. So again, the arrow, everything to the left of the arrow is the argument, and then you can put the body right after it. So, all right, there's that. Okay, so another thing we can do too, another shortcut like syntax is, let's go over map. So what map does, map is a prototype method on all of the arrays, and what it does is it takes in an array, and then it passes each item in the array through a callback function, and the callback function will modify and change that value. And then map will create a new array, and it will take those new values and stick them back in at the same index. So let me show you an example. It looks a little better if you can see it. So squares gets array.map array, and then I'm going to put an arrow function in line like this. So what we can do is we can go n, and then let's go n times n. All right, and let's go console.log squares. All right, oops. What did I do there? Oh, because I'm passing it. I'm sorry. I was thinking of the homework I have you recreate map, and that's why I was thinking you pass in the array as a first argument. So, all right. So yeah. So as you see here, it squared all of the different values. So the way this works is that this callback function that's passed in, this argument is the first item that gets passed in from the array, and then in here in the body we're returning the argument times the argument. So in the arrow function, if I use parentheses instead of curly braces, then it's expecting a single expression, a single line that will be returned by default. So this right here is equivalent to what I am writing right here. All right. So these two blocks are equivalent. So array.map, and then you pass in the shorthand syntax like that. The return here is implicit. If you use parentheses, it knows that it needs to return whatever line is there. So use this if you can. If you have, don't write it this way. Write it this first way if you can. It is a little more readable once you're able to. Once you get used to it, it's more concise. It makes it a little more easy to understand. So use this approach by default if you can. All right. All right. Okay. So here's the next thing. So const foo. All right. So we have a function down here. So let's say that. Well, let's call this square. All right, so this function is going to square whatever number comes in. So we have n, and we can return n times n. All right, so if we come down here, let's go const squared value gets square it, and then we'll pass in a 5. And then console.log squared value. All right, so print that out, 25. All right. So something we can do here is we can say n gets 10, like that, in line, and it gives it a default value. So now, when I run this, we see 100 printed to the console. So what happens is when in square it, this function is invoked, it's going to say, all right, is n defined? And if it's not defined, it's going to give it a default value of 10. And so we didn't pass in anything here. There was no argument, so n is undefined. So that way, so right here, n gets assigned a default value of 10. So it returns 100. So there's instances where you would want to have a default value specified if the user leaves off an argument. But yeah, so that is how you set a default parameter. All right. Okay. Any questions about this stuff, about arrow functions and some of these basic things that we've covered? Okay. Let me see a 1 to 5 about arrow functions. All right, here's a question. Can I do an example of, or wait, I saw it pop up on my phone, but now it's, oh wait, okay. All right, let's see here. An example of this in a for loop. So writing an arrow function inside of a for loop, so like running it inside of a for loop. Is that what you mean? Let's see. So, all right. All right, let me know if this is what you're thinking. All right, so what we're doing here, so for let I get 0, I less than 10, I plus plus, and then const square value gets square at I. So it'll pass in a 0 at first, so a 0 will get logged, it'll pass in a 1, and then a 2 will be 4. So I can run it, passes it through like that. Let me ask though, why, let's see. Yeah, what is the, and I saw some thumbs up on this too, what are people curious about within a for loop? Because there's probably something that I explained wrong. Because that question's a little, and maybe like just unmute yourself if you want in the video chat, and then you can just ask it out loud.
So in the pre-coursework, I ran into a problem trying to do the recursive function, eloquent JavaScript recursive function.
Okay.
Because it just kept going on an infinite loop, and I just couldn't figure out how to get it to stop. Oh,
okay. All right. We'll get into that a little bit later. I'm going to cover some other stuff, and then we're going to dive right into an explanation of recursion and all of that. So, yeah, we'll be going into that in just a little bit. All right. So, okay, so pretty much the trickiest thing with arrow functions is just that it's a different syntax. That this keyword is not explicitly set in it. Later I'll explain that, and you'll be able to see that difference a little bit more because we'll go into this, the this keyword for a minute. So don't worry about that part of it right now. But again, it's just kind of different syntax. They're little shortcuts. A lot of the stuff in ES6, it's not fundamentally really changing the language that much. It's just little shortcuts for common things. All right, so we're going to move on to the next topic. All right, so this one's pretty cool, it's pretty easy. So if we do, all right, so let's do const name get spend, and then now let's go const greeting, and then there's a thing called they call it a template literal. So it's a new syntax that it replaces string concatenation. So in here I can say hello, and then I can do $, curly brace, and then now I can reference a variable or put an expression inside of here. So I can say, I can create this this string, and then it's like this fill in the blank. So it says, insert, some JavaScript right here in the middle of the string. And so now if I go down and log greeting, let me see, hello Ben, how are you doing? So this essentially replaces the need to have to go, it's like quotes and plus, and you have to do all of this like string concatenation. You don't have to do that anymore with these, and so it's pretty amazing and saves a lot of time. So yeah, so template literals. All right, so here's the next one. All right, so let's say that now I have an object called user, and so I'm going to set an empty object here, and then now I want to add this name and this greeting to this user object. So I could go name, greeting, greeting. So these are, this is the kind of the old way of doing it. The new way that you can do this, when the property name and the variable name match in this instance, what you can do is you can knock out that first part. You can just write name, comma, and greeting, comma. So it's kind of a shorter syntax. So you see here, prints out the user greeting, hello Ben, how are you doing? Name Ben. Not sure why this is barking at me, but anyway. All right, so if we go into, let me open up my editor real quick. So in the homework and stuff that you'll be working on tonight, you see down here we have these different function names, and I'm using that same ES6 syntax to export them. So these are the recursion, ones. We have, check matching leaves, and so these two, they match. This is a function, and then I have the function name here. So instead of me having to write property name and then the value, I can just do this little shortcut like this. All right. Behind on my email. Yeah, I usually just don't even open a lot of this stuff. All right. Let's see. It's back open. Okay, all right, so the next thing that we're going to cover is the spread operator. So let's go const nums, and then let's go 1, 2, 3, 4, 5. And then let's make a function called sum. All right. So now what this function is going to do is, let me just do this real quick. I'm trying to remember if arguments is actually part of it. Let me, yep, all right, okay, that's right. Arguments is not defined inside of an arrow function unless, yep, okay, arguments is not defined. All right, so there's something called the rest operator and the spread operator that we can use here to be able to do a couple cool things. One is with nums, what we can do. So if we had, A, B, C, D, E, F. Let's see, 1, 2, 3, 4, 5, 6. Oh, all right. So right here I have these. I have 5 different parameters that I've specified that would represent 5 different things being passed in. So if we wanted to be able to, well, let's do this. A plus B plus C plus D plus E. All right. So if I wanted to be able to, I want to log those out, and I want to pass them in. One way that you'd think maybe you could do it is you could go, nums0, nums1, something like that. There's also .call that you can use, but I'll go into that a little bit later, or .apply, I mean. But what we can do is we can go nums. What this is going to do is it's going to take our array and it's going to spread it out, and it's going to go 1, 2, 3, 4, 5. And it's going to take these numbers, and based on their index in the array, it's going to put them in the corresponding argument slot. So we run that, it says 15. So they all print it out. All right. So now, let's say that we wanted to make this a little more dynamic, because if somebody's going to add a 6 and a 7 and an 8 onto it, all of a sudden we're not handling that. So let's say that we want to handle a previously unknown number of arguments that are going to come in. So what we can do here is we can go ... args. And what this does is this gives us a reference, a variable, and it takes all of the arguments and it makes them into an array. So in this, and it's a real array. It's not like args on, it's not like args, or arguments that were, in ES5 or in function declarations where arguments doesn't have a lot of the same properties on it. It just has like dot length. It doesn't have push or pop or splice or anything like that. So this one is an actual full normal array, so you can do all the same cool stuff with it. So if we just print out args, you'll see that it prints out the entire array. We can also go, like, let's say we have x, y, so we want to be able to reference the first two arguments that come in. Then what we would see here is args would now, it would not have the 1 and the 2 because x and y are referencing the first two arguments that get applied. So this is the spread operator. This is called the rest operator. They're doing two different things, but they're related. One takes an array and spreads it out, passes it into a function. The other one takes a bunch of separated arguments and combines them into a single array. Okay, any questions about this? Yeah, okay, so arguments. Okay, yeah, so arguments is a default array that is built inside of functions that gives you access to all the different arguments that are passed inside of a function. They do not exist inside of arrow functions. So let me just explain that real quick. So if I do function sum, and then if I go arguments like that, it's by default. We didn't define it anywhere. It's created inside of every single function, but the function keyword has to be present. If it's just an arrow function, then arguments, this array is not created. Arguments does not have all of the same properties on it. So if I go pop, it's undefined. It's not a function. It has length on it, and there might be a couple others, but most of the useful and interesting methods are not on the array. So anyway, that's what arguments is doing. They don't exist inside of arrow functions. I mean, generally you're not, I don't know, you're not really using this very much anyway, just because you usually know what arguments you're going to be getting beforehand and how many. So, all right, any other questions about this topic before I move on? Again, these are just kind of some different little syntax things that you're not going to remember them all right now, and there's no expectation for you to, but we have a pretty strict linter. We're using Airbnb's linter. I've changed a couple things on it, but it's going to be pretty strict with you with the code that you write, just because linters are great at enforcing you to start to develop good coding habits, and just writing clean code and keeping it formatted correctly. So it'll be painful, and there's going to be a lot of questions we're going to get at first about why different things are breaking and why not to write code in a certain way, but anyway, it's all good though. All right, let's see alt syntax again for arguments. Okay, so there's that. All right, so again, that's called the rest, or the rest parameter is what it's called. All right. Okay, so now we're going to move on. And again, just look on Babel. If you go to Learn ES 2015, there's a tablet view. Let me hide these videos. All right, so I gotta refresh. Jeez. All right. Okay. So Learn ES 2015. If you go to there, then it has all of the different topics on here. Just these are all the main ES 2015 features or ES6 features. So you're probably going to want to just have this open while you're coding. You're going to be using this as a reference a lot. All right. Okay. So now I'm going to go over constructors and classes. So before, we would do something like this. We go function user options. We go this dot username gets username. This dot password gets options. So then what we do down here is we'd go var me gets new user, and then we pass in an object. And so username Ben, password 123. All right, great. All right, so what we have going on here again is user. This user is it's like a little factory. It takes in some options, some different parameters, and it creates a new object and spits it out. So if we come down here and print out me, you're going to see this object gets printed out. So options is this object. We pass it in. We specify username. We specify a password. The reason this function behaves differently and it returns a function is because of this new keyword. Essentially, it's when we pass in new, it's initializing a new object right here, and then it's returning that object right here. So it just takes this function and it transforms it into, they call this a pseudo-classical instantiation. It's this is kind of one of the primary models for creating classes in ES5. We're going to just be doing it with ES6 classes. So yeah, options come in. It specifies the properties that you're going to have on the object. Essentially, it just makes it so it's a function that you can use to create all these different instances of unique user objects, or or whatever objects that that you're wanting to create. All right. So now let's transform this all into some ES6. So first we'll turn this into const, and then we're going to map this out. So now we're going to go class user. All right. So this underneath the hood, it's doing pretty much the same thing as what we were seeing before. There's a constructor property on it. And we're not going too deep into classes. We're just kind of superficially touching on them a little bit, just so you're kind of familiar with the basic syntax. So in here, this is where options would be handled. So you'd go this dot username gets options dot username, and this dot password gets options dot password. All right. So username and password. These are these properties. So when I say so properties that you want to find on an object, not methods, so not functions. So stuff like just the string Ben, like username, password. You define those. You attach those to the object inside of the constructor. Then if we wanted to add a method, so let's say we call it say hi. We attach it like this. And then we can go console.log. Let's go hello. Let's see. Braces. This dot username says hi. All right. So now this say hi method will be attached now to every single user that is created. So now if we go me.sayHi, clear this out and run that, you see hello, Ben says hi. All right, so now let's let's say in our code we're creating another user. So this one is you, and user, this will be Austin, and his password will be the exact same there. All right, so now we can go me.sayHi, and we can go you.sayHi. All right, so clear that out, print it, see hello, Ben says hi, hello, Austin says hi. All right, so so you can see that the function, it behaves dynamically, for each of the users. So because of this keyword. All right, I'm gonna pause for a second and just check some questions. Yeah, you use React. Yeah, you use these classes a lot. Ever since they've started making these, you see them. I hardly ever saw classes used. I mean, okay, you'd see it in libraries and stuff, behind the scenes a little more, but I see ES6 classes a lot more than I saw ES5 type stuff. But again, you know, React has a lot to do with that as well. So yeah, great. All right. Yep. So this is and again, they use the term syntactic sugar. They call it that because, again, this is just ES5 code. This all gets compiled down into ES5 code. So it's the same stuff we were writing before. It's just now we can write it in a way that is a little easier for us to write and a little easier for us to reason about. So, all right. So now we need to touch on an important concept. So if I go down and I go, well, let me knock both these out. And if I'm going to go console.log u. All right, so I'm going to console log u. We see we have Austin that gets passed out, printed out here. But then you look and you think, okay, where is say hi? You know, say hi is not on here. So say hi is on the prototype. All right, so what the prototype is, classes in JavaScript can have, like these objects, they can have a prototype. So I say object because everything in JavaScript pretty much is an object. So strings are actually objects. Arrays are actually built using built as an object. Yeah, that's yeah. Strings, objects, arrays, functions are technically objects. So they're all kind of built on top of objects. So this class, what we can do is on this class we can specify what's called a prototype. And then on the prototype we can have some different functions on there that are shared across all of the instances of this class. So it's the stuff that's on the prototype of user will be shared across me, and it'll be shared across you. These two instances right here. We refer to this as like the instance of a class. So the prototype it will contain contain different methods or different properties that will be shared across all the different instances. So that way the code doesn't have to be duplicated. So that's why when we create a new array, we can go array.push. And so the actual array right here in memory, this array object does not contain the push method, but the array's prototype tells the computer where to look to find the code for the push method. It's on array.prototype. So and it looks like this. It's array.prototype. So generally, you're not really going to be touching the prototype. Shouldn't really be messing with it that much. We're just going to touch on it a little more just conceptually right now than than actually like having you play around with it a lot. But here, I'm going to try my famous drawing again. So here's our prototype, and when we make new classes, we can what we can do is we can attach some methods onto our prototype. So these squares are the methods. All right. So when we use this to create, class to create our different instances, and so we'll say that these triangles are the different instances of the class. So for example, array. So these are all the arrays that we're using. And when we do this underneath the hood, this yeah. Or an Imperial Walker, I guess, kind of Star Wars. All right. So anyway, so underneath the hood, the array constructor is being used. And so when we attach these methods onto the prototype, what happens is on this array right here, when we try to use, we're trying to invoke this. I'm doing it kind of dotted because we're saying we want to go .push on it, but the .push really doesn't live here. But the array knows to go up and look at its prototype up here. And I am getting an actual stylus, so I'll be able to draw. So great for you guys in the future. But so the array is going to see, okay, it wants push. So the array is going to go and look up on the prototype, and it's going to see, oh, here's push right here. And so then this code is then given back to the array, and it runs .push and pushes something onto this instance of the array. And so it makes it so you can have all this code up here associated with an array, but it's not getting copied and duplicated in memory every single time you're creating a new array, or a new string, or a new object, or a new function. So that's kind of how the prototype works. So if so with this user, when we add this say hi here, it's being added to the user prototype. So that's why we don't see say hi on here. But if we run it, we go me.sayHi, and what happens is, the computer's going along, it sees me.sayHi, so it's going to go look at the me object, and it's going to say invoke sayHi. Me's going to say, I don't have a sayHi method. But then it goes and looks on its prototype, and it says, hey, do you have a sayHi method? And the prototype says yes, and it gives them the sayHi method, and it comes back here and it invokes it. So that's just kind of a high level what prototype is, just so you've kind of heard it, but we're it plays in and it's important to understand, but it's not it'll be kind of a brown bag lecture type of a thing that we're going to go over in the future. All right. Okay. All right. So now I'm going to. Well, all right. Okay. So we have this keyword. So if you want to know what this refers to, so instead of this function, if you want to know what this refers to, the general rule of thumb is look at where the function's being invoked. Not where it's being defined, but where it's being invoked. And where is it being invoked? Down here. So look at where it's invoked, and then look to the left of the dot. And so we see me. So the me object, that is what this keyword refers to when sayHi is invoked. If we were to invoke it with u.sayHi, then we look inside the sayHi method, we look for the keyword this. This refers to what is left of the dot. So this user object right here. So it allows you to dynamically set which object you want to refer to. So it makes this method that can be reused, and we can use different properties that will be, they'll be different across every single user object. All right, so that's what's going on with this. And another important thing to know is you can explicitly set this. So let me show you. So let's make a function down here. We have to define this with a. We have to use the function keyword here because this inside of an arrow function is not set. It just refers to the this for whatever function the arrow function is inside of. So if we go right here, what we can do now is, so let's all right, let's do this. Let's go console.log, and then we'll make our string literal. We'll go this dot username says goodbye. All right. So you have this function right here. Right now, this just refers to this function object. That's what this refers to. So, but if we want to be able to make a function like this that we can kind of reuse it with these different objects that we have, there's 3 different ways that we can pass or specifically set what the this context is. We can set what the this keyword refers to. So the first one is called .bind. So we can go const bound say goodbye is equal to say goodbye dot bind, and then we can pass in me. All right, so what this does is it takes the function and it goes in and it explicitly sets what the this context should be for that function, and then it returns it. So as a copy of it. So now we can go bound say goodbye, invoke it, and then what are we going to see? Ben says goodbye. If we change this to Austin's, we'd see Austin says goodbye. All right, so that's the first way to do it. So the next one is we can go say goodbye dot call. and go .call, and then we can pass in me. So we'll just do me right here, so they'll all print out the same. See, Ben says goodbye, Ben says goodbye. The next one is say goodbye dot apply. Pass them in like that, and you'll see they all print out. So you're like, okay, those are all kind of doing the same thing. Like, why would you, like, what's the difference between them? So the difference is how they handle passing on arguments to the function that they're setting the context on. So let's say that down in here we also had an array of our well, x, y, z that we wanted to just randomly spit out right here. And we're going to go x plus y plus z. All right. So we're just going to have some random numbers we're going to put in. So here in bounce says goodbye, I would just pass them in like this. So you see, not a number because it's trying to do math with undefined things. So Ben says goodbye, 15. All right, if I wanted to do the same thing here with .call, I would go me, and then I go 5, 5, 5. I just pass them in. The first argument sets the this context, and then the other arguments are, they get plugged in their corresponding spots. Apply takes an array. You can see here, Ben says goodbye, 15, 15, 15. All right, so those three things are all doing exactly the same thing. Different syntaxes for writing it. I don't really have a preference for which one you need to use, but yeah, there's some slight nuances. So why not add it to the prototype? There's just some times where your functions, you may want to be writing them this way. All right. Okay. All right. .bind, .call, .apply. All right. We're going kind of fast. I'm lightly covering a lot of material. What I'm trying to do here is give you a little bit of introduction to a lot of stuff. Some of this should be review, and then I'm going to turn you loose on the project, and then that's when you're really going to learn this. That's when you're going to figure it out. Honestly, about half of you, your eyes are probably glazed over at this point, but everyone print out into the console, bind, call, and apply. How do you feel about those? Let me see a 1 through a 5. All right. Generally, I've learned too that I should minus 1 or 2 from every single answer that I see, and that's usually a more accurate representation of what everyone's feeling as well. Yeah, what I'm gonna set up there's an anonymous polling thing that I've been playing around with that I'm gonna set up and use in the future. So that'll be a little more effective, I imagine. All right. So all right, kind of an introduction. You can come back and rewatch this part of the video in the future. And anyway, I have some other stuff that I want to touch on beyond this right now. So, all right, I'm going to delete this. Okay. So this first project that we're doing is kind of this broad attack at JavaScript. It covers a lot of different, some of the nuances of the language, some of the more advanced things. A lot of you probably won't even finish this project in the next 3 days, but this can be something that you can revisit, something that you can work on, and this is going to help lay and build that foundation, for strong JavaScript that we're going to carry and need and use throughout the course. All right, so let's go. All right, let me pull up my notes again real quick. All right, okay, 3 more things. All right, closure. Okay, so closure scope. All right, let's play around with this and see what's going on here. All right, so if we go, well, let me just check this chat real quick. Okay, all right. So let's go const foo is equal to this arrow function. All right. So all right, so we have our function right here. So functions in JavaScript, they can be they can be used like any other value in the language. They can be used as a, they can be passed like, or just like other values, you can fill up an array with functions. You can make them properties on an object called methods. You can pass them in as arguments to functions. You can return them from functions. You can add properties onto them. It's that they behave. You can use them just like any other value in the language. There's nothing too special about them in that regard. It's a block of instructions that you can pass around. So what we can do here is let's return an arrow function like that. So what we're going to do, we're actually going to call this outer. And then in here, we're going to go const.log hi. All right. So now if I come down here, let's go const inner gets outer. All right. So if I come down here and I go inner and I invoke it like that, then you see that hi gets printed out. Because what happens is when we call outer, that's this function, that block of code, it gets invoked. So when we do these open and close parentheses, it makes it an equation. This is this piece of code right here has to be evaluated before it knows what to assign to inner. So it doesn't know what to give to inner yet. It has to go and run outer, run through those instructions, and see what value bubbles up to the top, and then that's what it's going to give to inner. So when the computer's running, it's going to go, it's going along, it sees const outer. So it gets this variable and it assigns it this function. Then it comes down here, it says const inner. So it says const inner is equal to the invoked outer function, or whatever gets returned from outer. So then outer gets invoked, it comes up in here, it runs down, it sees a return statement, it grabs this function, returns it out to here. So this is exactly the same as saying that. Those are exactly the same. It's just a function being returned from inside of another function. All right. So any questions about this basic idea of just returning a function from a function? Okay. All right, so it's pretty straightforward. So now let's say we want to break out hi. So let's go const greeting gets hi. All right, so you have console.log greeting. So, this should behave, exactly the same. Oh. What am I doing wrong here? Oh, it's because I'm redefining a const. That's why it's not liking it. All right. So hi, you see hi gets printed out. All right, so what closure is that this function that's getting returned, inside of that code, we can reference variables and values that exist outside in its parent scope, out here. So greeting, runs here. So you can see that it still maintains its reference to hi. If we tried to, so let's change this to let greeting get sup. All right. Now, everyone, I want you to type into the Slack channel, are we going to see hi or sup appear when I run this code? All right. Okay, so now we come in, run it, and moment of truth. Hi. All right. So what you see here is that even though this function, this code gets returned to this spot, it's still looking back in here where it was written to find its parent scope. So the function is going to go back and it's going to look where it was written. And so that's the whole idea behind closure. It's that this inner function is going to look here for greeting and not here. Yeah, so It's just, it's, look at it the way that it's written, and at the time that it's written, that's what, yeah, closure scope. Yeah, so it's the idea that the scope of that inner function is its parent scope is where it was written and not where it was invoked. So the function is invoked here, but it's not going to look here for greeting. It's going to go back and look where it was written, which is inside of this outer function. Okay. All right. We use var instead of let in the function. So if we change those, so you see that, yeah, they'll behave the exact same way. And it's because var, again, is still function scope. So yeah, it behaves the exact same way. All right, so this is the entire idea behind closure. It's used a lot in interviews because it's, yeah, I guess people think that it can be a pretty good assessment of how much like advanced JavaScript I don't know. The merits of that are debatable, but this is something that you'll probably get asked about multiple times. So this is just pretty common, pretty common interview question. Stuff like this. So what in practice, how we would use this, because this right here, like, okay, maybe you're starting to get the concept, but what can we make with this? How, what's something cool that we can do with it? So what we can do with it is if we a user maker function. So kind of a different style for making a an object. We have a function here that's going to return an object. All right, and so then on here, what we can do is we can have we can have private variables. So what we can do is we can say of our options, and then down here we can go const username gets options dot username. So in practice, you should use just a React class. But again, I'm showing you that this is kind of a style that you can use to create private variables. So maybe you wouldn't use it to make like a class for something, but you could use this, for something else that you'd be working on your code. Don't worry about it too much right now. All right, so let's go let password gets options dot password. All right, then return. We're going to return an object, and then on the object we're going to have a get username, which actually I want to test this out. This is just going to return this dot, or actually, yeah. We're not, sorry, I was thinking of this for a second. Okay, so return username. Then let's go get password. Return password. All right. So now if I come down here, I can go const me gets user maker. Now let's go username Ben correct battery horse stapler. All right. If any of you read XKCD, you'll know what that means. You'll understand that comic too later on in our course as well. We go into the some of the more science behind that. All right. So now me has a get username. So instead of returning, I'm just gonna, well, no, I'm gonna return it. So let's go console.log me dot get username. Oh, get username is not a function. Oh, what did I do? Did I spell it wrong? Yep. All right. All right. So Ben, you see it print out. So they call this getters and setters. So I have get username. It's getting the property. But on me, if I were to console.log the me object, if I ran that, you see that it has the functions on it, but I don't actually have access to the username property. So I can't, from me, I cannot set it, or I can't do a me.username gets new username. You know, if I do that and run it, it still says Ben. I can't access it. So what this does is this creates a controlled access point that makes your code more stable. It makes it so it's really hard for you to accidentally mutate some important data. So like username. So like right now, from this me object, there's no way for me to change username or try to change username or try to change the password unless I specifically create a method that does that. So I could go set password, and then I can go password gets new password. So I can do something like that. So instead of get username, I'm going to go get password and then right here I'm going to call this set password, and then I'm going to say I missed my 1, 2, 3, 4, 5 password. So now we clear this, we run, and you see correct horse battery stapler, and nothing's getting returned, obviously, so I can get rid of that. But so correct horse battery stapler, or staple, maybe I think that's actually what it is. But you see that the old password's printed out, and I set it to something new, and then the next one is printed out. So essentially, it's what's going on here is that this is it's private. It's you're not able to actually mutate the one directly unless you mutate it through this interface that we specifically defined here. Interface in loose terms, not in like a strict like C# form or whatever. But anyway, don't worry about that. So anyway, that's what Clojure is. Clojure it creates these different variables that are held here. These functions can go out and access it and change it. And you see that the variable it stays there and it exists between function invocations. So we see console.log me.getPassword. You know, because if we were to set the password and define it, you know, and set if password, I mean this will look dumb, but if it was let password get, you know, correct, you know, whatever, if we defined it in this function, every time we invoked it, the function would be created. It would create this new variable, and then it would set it to something new. And then when the function is over, there's no more external references to any of these variables, so it all gets deleted. The computer deletes it all because we don't have a way to access it anymore unless we run the function again. But then when we run it again, it's just going to initialize it back to this original state. So it means that in memory, you've created this way to kind of save these save these properties. So. Yeah. So yeah, and these could be const, let, or var. The point is just that they're variables inside of this function scope. There's nothing like magic about it. Like it's just that, you know, these could be functions, they could be arrays, they could be whatever, but it's just variables inside of this function scope. Inside of this function scope can all be accessed from inside of these functions that are methods on this object that's getting returned. So this is Clojure. This is exactly what it is. And so there's a bunch of problems on it in the homework that will help you explore this topic more thoroughly. So what questions do you guys have about this? All right. Okay, everyone. Looks like someone's typing a question. Yeah, so the reason that password is let is because I'm redefining it down here. I initially wrote it as let when I created this because I knew beforehand that I was going to create a set password method that was going to override it. Okay, so yeah, because it's changing, it's a let. If I made this a const, then there would be an error as soon as I tried to reassign it. But then username, I'm never changing it, so it just stays as a constant. Yep. All right. Any other questions about this? Everyone, give me a 1 to 5. Regarding closure, just closure in general. Okay, great. All right. Yeah. So as we as you work through it, and again, I'm going fast. Don't feel bad if this is if you're feeling a little overwhelmed with this. Just do your best. Absorb as much as you can. Be a sponge. It'll be a lot easier tomorrow once you've slept on it and had a chance to play with it. All right, so closure. This is closure. Again, you can come back and review this in the lesson video. All right, so now let's go to, all right, our second to last topic, which is recursion. All right, so this is, well, all right, I'm not gonna set you up with that. Okay. So, all right, so let's say we have let counter, and then we'll set it equal to 10. We'll go while counter is greater than 0. Console.log counter minus minus. Okay. All right, so if we come in here, clear, run, we see 1097654321. Okay, so an important thing to understand with recursion is that recursion is just a loop. It's just a way of looping or iterating over some data. It's just like a for loop or a while loop or a do while loop. Recursion is just another form of iteration. And there's times where recursion saves you a lot of code. There's points where it's a lot easier to write something recursively than it is to try to do something in a for loop. It can get really, really complicated to try to build something with a for loop. And there's some examples of that in the project homework that I'll go over. So what I'm showing you here is that we can now rewrite this as a recursive function. So what we'll do is we'll come down here and we're going to go const countdown, and we're going to set this equal to an arrow function, and then this is going to take in a value. So, all right, so essentially it's going to be, kind of this, we're going to do the exact same thing. So first thing we're going to check for is if value is greater than 0. Then we're going to console.log value. And then we're going to return countdown value minus 1. Okay. So, well, I'll just finish this out real quick and I'll walk through it. Then I'll go return value. All right. So what's going on here is that when 10, what we'll do is we'll invoke it right there, and I'm going to knock that code out. I come and clear this, run it. You see 10.987654321. Let's figure out why this works. So with countdown, this function, so value gets passed in, value is 10. So this is the number 10. You just think of it that way. We have the number 10 coming in. So we're going to see, is 10 greater than 0? Yes. So we're going to come down here, we're going to print it out. That's where this 10 came from. Then we're going to go return countdown value minus 1. So this function is now going to wait, because in order to return, it has to know what this is equal to. And so while it's figuring this out, countdown, now another level in, it's going to open up another countdown function. But this time the value is 9. So it's going to come through and it's going to say, is 9 greater than 0? It is. So it's going to log out 9. That's this. And it comes into here, return countdown, and then it's going to pass in 8. But this function also doesn't know to return. It doesn't know what value to return. It has to wait for this whole expression to finish. And so it has to wait. So then we pass in 8, and now a third countdown function is open. And so with recursion, you have all these different functions, these copies of the function that get opened over and over and over and over again. So if we did this, let's do this with 3. I'll walk through that a little bit better. All right, so this is 3, comes in, 3 greater than 0, yes. So then we come in, well, actually, let's do 2. Let's just even do it a little less. All right, so 2 comes in. Is 2 greater than 0? Yes. This evaluates to true. So this first part runs, console.log value. So it prints out the 2. That's the first 2 that we see. Return, countdown, value minus 1. So it passes in 2 minus 1, which is 1. So it's calling itself with the number 1. So then this hangs open because on that top level, this function wants to return, but it doesn't know what this equals yet. It doesn't know what this is equal to yet. So it passes in a 1. So there's a second countdown function that gets created. So it's kind of like this. So here's a 2 that was passed in. Is 2 greater than 0? And so then now it's going to pass in a 1. So then another function is opened up that runs. But this time it's a 1. So then it comes down here. And it says, is 1 greater than 0? It is, so it logs out 1, change that to a 2. Then it's going to return, countdown, and then this is going to be a 0. And so then it creates a third function. All right, but then this time it's a 0. So it's going to come down to here, and it's going to say, is 0 greater than 0? No, that is false. So then it comes down here, and it says, else, return value. And so value is 0. So this function then exits and returns a 0. So then as we come up into here, this value right here is a 0. And so then it returns 0. So then that all simplifies down to a 0. This right here returns and becomes a 0. And then now that returns, and all of this function finally closes up, and this right here simplifies down to a 0. So if I were to come in and let's change this to value, 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 and then let's go countdown, value minus 1. And so we actually log this. So you'll see 2, 1 got printed out from in here, but then 0 is that final value that got printed out. Yes, final value is 0. All right, so that is recursion. It calls itself that. The key is you have to have what's called a base case. This right here, this else return value, that's the base case. That's the point at which the function stops calling itself. It's like, that's the part of the recursion loop that's like the for loop, where we go, let I get 0, I less than 10, I plus plus. So that's this part. This is the base case of the for loop. This will break as soon as I is not less than 10, the loop stops. This right here is the part that breaks us out of the cycle. You need to be returning what you are invoking. So we're returning, so like another rule of thumb generally is when you're calling the function recursively, trying to create a loop, you should be returning whatever the result is from calling itself. So wherever you invoke the function inside of itself, that should be returned. And then the next part is that your value, or that you're iterating with, needs to be moving towards your base case. It's like in the for loop. So the for loop, we have let I get 0, I less than 10, and then I plus plus. Right here, I is going to be incremented, it's going to increase, and eventually it's going to trigger the base case and break out. If it didn't, if it was, if we just did while true, this will always be true because it's just true, then the for loop would go forever and the browser would crash, because there's nothing that would ever indicate it for it to stop. No other code could run or execute because this is taking up all of the browser's energy, and so the actual Chrome browser would crash. So in recursion, it's a little easier, like to accidentally trigger an infinite loop is what they call it, where the function just keeps calling itself, and nothing ever tells it to stop calling itself, and so you hit an error that says maximum call stack size exceeded, and then everything breaks. So, all right. So the interesting thing about, well, no, we'll talk about that more later. All right, so that's recursion, and you'll have a chance to kind of play with it. Yes, won't go forever until the resources are spent. Yep. Yep. The bigger the computer. Yep. Exactly, until the energy death of the universe. So, all right. Okay, let me see. Let's see. All right, so maybe bring up the call stack. Okay, and we're going to be going over this more and more and more. And so this is kind of a, it touched on this a little bit in the eloquent JavaScript, and then this we're doing a little bit of an introduction, kind of start getting your hands dirty with it, and then your homework and then the little problems that we're going to have are going to dive in a lot more with recursion. So you'll have many chances to practice this and work on this. All right, let's see. All right, let me see a 1 to 5 on this. Obviously, it's hard to know without actually diving in and writing it yourself, but at least conceptually on a high level, maybe it's okay. All right, no shame in putting a 0 or a 1. Yeah. So it's okay. So I mean, and this is the purpose, so you can high level understand the concept, and then when you're actually asked to write it, it's going to be very different. And so we'll get in and have you guys actually writing some of this code. So and don't feel bad if this is hard, because we're starting at an advanced level. I mean, it's pretty amazing that we're starting with this on day 1. I mean, we'll see how the homework goes, but this is we are starting at a very high level, because we are confident, just with how much we've worked with you guys and how much you've already done, that that you guys can learn this. It'll be hard, but we are confident that you guys can become very comfortable with all these concepts. Okay, all right. Okay, so last thing, this is kind of a side note. Has to do with something that you'll see in the homework. Great. All right. So, all right. So iterating over an object. All right. So something that you may have seen is, you can go for. Sorry, I'm used to saying for var key. For let key in object. And then printing out the object, so you can reference the key in there. This is generally considered pretty unsafe. You can accidentally access properties that weren't intended to be accessed, or when those properties are set, they weren't set in the proper way. So generally, I want to encourage you to stay away from using a for like this syntax. I would encourage you to stay away from it. This is how I want you guys to iterate over keys on objects. There's a global object called object with a capital O, and has a property on it called .keys. And then when you pass an object to it, it returns an array of strings that reference all of the keys that should be iterated over that are on an object. So if you go object.keys object, and then you can chain off of it because it's an array, and then you can pass in a then you can call call for each. I'll walk you through this in just a second. All right, so if we clear this and run this, great. All right, so you see everything printed out. So here's what this looks like. So we have this object, global object. We call .keys on it. .keys object. This returns an array that's going to have the strings x, y, z. When you specify an object key, it is always turned into a string. So this right here simplifies down to an array of strings, and arrays have a for each method on it. so then we can then immediately call .forEach. This is called method chaining, and you want to write your code like this. As you get better, this is how I want you to write your code. I want you to be using for eaches, .forEach over for loops. Like, you don't have to do it right now because you're still learning and getting better with for loops. So I want you to be using for loops as well, mixing it up. But eventually, you're wanting to just be using for each. Use keys, use these methods, chain them like this. This makes the code very readable. Makes it pretty stable. Anyway, this is eventually what we're going to work to and have you guys writing code like this where you're chaining different methods together. Each method returns a value that then gets, that has a property that can be accessed on the next. And anyway, it leads to writing some very readable, very concise, and clear code. And you can do a lot with it's more readable, you're writing less, and just a lot of good benefits to it. So this is how I want you guys to iterate over objects. So I don't want you to be using for var key in object or let key in object. I want you guys to be using this, object.keys. So I know that we'll probably forget some of this, but there's that. You can check that. You can reference that later. But yeah, there's some parts in the homework where you'll need to iterate over some objects, and so that's how I'd like you to do it. Okay. All right, that was a lot of stuff. A lot of it should have been like somewhat familiar. Or you should have had some exposure to a lot of those concepts. So hopefully it wasn't just a total start from zero. If it was, no worries. You'll have a chance over the next few days to work on homework and work with your peers and your classmates as well as instructors to be able to refine this information and be able to solidify that knowledge. Okay. Questions? And also feel free to unmute yourself and ask the question verbally. All right. Last thing, real quick. Give me a. We'll have better polling. We'll have a better polling system set up for next time. But give me another 1 to 5 right now for for how you feel about this object.keys iteration stuff. Okay. All right. So good, no worries. This one seems like there's a little more. I went kind of fast on this. So let me just log these out individually. I'm just going to go through this real quick. So if we go const keys gets object.keys object. So let's I'm going to comment this out right now. All right, so let's log out the keys. So this is just the object.keys part. Object is a global variable, kind of like there's array and some other ones, string, number. So you run that, and you see x, y, z. So it's an array of all of the keys that are on the object. So object.keys obj prints that out. Boom. So an array has a for each method on it. It's a way of iterating over an array. So if I just did 1, 2, 3 dot for each, I can then pass in an arrow function like that that's just going to log out the value that gets passed in. So you see 1, 2, 3. Let me write this a little more verbosely in case that syntax is a little more confusing. But if I wrote it like this, that's doing the exact same thing. All right, so for each is just a method that it takes in a callback function, and that callback function is going to be called over and over again, and it's going to be invoked in turn. So each item from the array is going to be passed in order of its index to the callback function in turn. So n, the first time it's invoked, is 1. The second time it's invoked is a 2. The third time it's invoked is a 3. So 1, 2, 3. This callback function gets called 3 times. Okay. So what we're doing down here is we're saying object.keys object, and this first part gets evaluated. The computer evaluates this part first, so then it's that array up here. You see this XYZ. That's what this turns into. And then it goes for each, and then it gives us the key, which is the item from the array, and then it just logs it out. This is a little better, like that. So, all right. So, anyway, essentially, it takes a lot of code, a lot of more complex code, and it boils it down into a format that eventually, with practice, will be easier to read and will contain more meaning than trying to keep track of a whole bunch of different variables and stuff inside of a loop. That can get kind of complicated. All right. So yeah, so when you come to it, then you'll have a chance to to figure in and really solidify this part of your knowledge. All right. So here is the repo for tonight. I'll post this in here. All right. So what you're going to do is you're going to come in. You're going to fork this. So you're going to fork this repo. Push this fork button, and then you're going to clone it down. So similar process to what was in the JavaScript mini bootcamp. You're going to fork this, clone this, then you're going to run the command npm install to add all the node packages that you need. Then you're going to run the command npm test to run the tests. Let's see, there might be some ESLint stuff that actually I just remembered. Okay, anyway, I'll touch on that later if that's an issue. Okay, so then what you're going to do is you're going to work through the files. You're going to write code to fulfill the tests, just like in the JavaScript mini bootcamp. And so this is a suggested order. You can do them in any order you'd like, do them out of order. But the first thing I want you to do is to go through, like, my recommendation is to start here with es6.js. And you're going to go through and you're just going to refactor this code. So this file does not have any automated tests. So es6.js, this file does not have any automated tests. You're just going to come in and rewrite the code. So that way it fits the ES6 features that we went over. And so you'll see here up top, it'll say like const, the arrow function indicator, default parameters, arrow function. So it says some of the different things you can use. So, rewrite it. You can rewrite this in JSBin so that we can, test it to make sure it still works. But the point is, refactor this so that way it's using some of the ES6 features that we went over today. So this is just a chance to kind of get in there and reuse some stuff. Yeah, then I want you to go through the arrays, objects, this.js, closure, and then finish with recursion. And so, yeah, array, closure, recursion, those ones, and objects, those all have automated tests. This.js is another one that has no automated tests. Okay, then if we come in here, so like arrays, for example, you have a couple different functions in here that you're going to be writing out. So like each, this is essentially for each. You're going to be implementing your own for each function. And so these are all taken from underscore.js, which is a library of common functions that you can download. Anyway, there's links to it. You can go in there and look at it. I've been talking a lot. We've gone a long time. So maybe get up and stretch your legs, walk around for a minute, get a drink, and then come back and start working on it. And then what we'll do is ask questions in Slack. We can also, open up Google Hangouts. What we'd like to do as well is we're going to keep this video call open, this Zoom conference call open. And then you guys can stay on in here. You can ask questions publicly and just kind of create more of a classroom environment. I know it can be a little more intimidating because there's so many people, but yeah, but just so stay in this video call when you work on it, and please ask questions. Get involved with your peers on this, and do your best. Any questions? Okay, last thing, when you're done, submit a pull request back to the original repository. It makes it really easy so we can compare and contrast your code with what's already there, and there's a really nice system already in place where we can go in and write down all of your, or we can make comments on your code and give you feedback. So we're going to give feedback to every single one of you, based on how much, just line by line. We're going to just walk through it real quick and give you suggestions on different things that you can improve on. All right. Okay. Super excited to have you guys in class. It's we're starting off at a sprint, and honestly, I think I think it's probably going to get easier as the week goes on, and then ramp up a little more in difficulty, more into next week. But yeah, we're starting out pretty fast and hard. So yeah, let us know if you have any questions. Austin and I will be around 100%, or at least me for questions, until until the end of class. And then after that, still, you can still reach out. We'll get back to you. This is my full-time job, so reach out to me and I'll get back to you at some point. Outside of class hours, no guarantee on how fast that'll be, but yeah, please reach out rather than just like being stuck and going in circles for half an hour. Please reach out with any questions. We want to get you moving on if you're stuck on something for too long. All right, that's it. So